today we're installing a Sol-Ark 15K on my house, and I'm going to be backing up most of the house. Now, the nice part about the Sol-Ark 15K is it has a built-in 200 amp transfer switch. So theoretically, my electrical meter that's on the other side of the wall right about here could simply feed into the input of the Sol-Ark 15K, and the output of it could go to this main panel up here, which is great for most applications. However, my application, not quite. The reason being, we have 2 electric vehicles, we have a swimming pool, and a few other heavy loads that I really don't care to back up. And if they're running at full load, I don't want to have the power go out and have that overload the inverter, because the inverter can't supply a full 200 amps. And I really don't need a second inverter because it's not like I need to charge my car when the power is out. And the thing is, though, I will be putting in an outlet, you'll see later, so that I can do that. But ultimately, this is going to become my grid panel. And in this space right here next to it, I have room where I can put my critical loads panel. I'm going to show you all about that here in a bit. Now, this house does have AC coupled solar on the roof. For the short term, I'm going to be AC coupling that into the Sol-Ark. I'm going to essentially make it not backfeed any power to the grid. I'm going to store the excess in my batteries, so that way I can use it at nighttime and I don't have to take a penalty on the power I sell back to the grid. But yeah, we're going to get a little bit more in depth here. I'm going to show you some of the things I've looked into before. You can see there are some holes in the wall. Maybe they're out of shot, but either way, we're going to get into the details and you're going to see exactly how this is going to play out. Now, you may not be able to see very clearly here, but the reason I drilled this big hole in the wall is because there are some communication lines that come down through here. This wall section is framed with 2x6s, but as you can see in here, there's some communication lines, and my panel's not 6 inches deep, so I'm just going to route those communication cables behind the panel. Now, to be frank about this, we don't use any of those lines. They're all coax, and we, in 2023, don't have coax TV service, so I'm not too worried about that, but I do need to make sure that they don't get cut because my goal is not to demolish them at this point. This here is an add-on sub panel that was added at some point after the house was built, and there's quite a few things wrong with it. Let me get you guys a close-up and you'll see exactly why some things need to be fixed. So it may not be apparent at first, but you're looking right now at the 2-pole 70 amp breaker that feeds to that sub panel. They used aluminum cable here, and if you look really closely, there's some strands up here, and it looks like the cable didn't fit into the breaker, so they cut off some of the strands to make the cable fit in the breaker, and that is just totally wrong, no good. If we're running heavy loads for a long time, this can heat up and cause some serious issues. So you'll have to bear with me on my camera work here. I'm running handheld, but you see up here, this is a single pole 20 amp GFCI AFCI combo breaker, and if you look in the back, it has its neutral wire back there. It runs down here in this panel and over, and if you look over here, oh, what do we have here? It's not even connected to the neutral bar. What the heck? It's really silly stuff like this that's made us decide that this was not installed right, and there is some cleanup to do here. Another thing to take note of, they added a surge protector over here. And how did they run the wires? No proper cabling, just drill a hole in the side of the panel and it'll be fine. My plan essentially is to yank out this panel completely. The Sol-Ark is going to go in this area. I'm going to run a wireway across the top. I'm going to have some flex conduit through the wall coming into the Sol-Ark, and that wireway is going to allow me to take all the circuits that come into this panel, land them in the wireway, then I can run them over and down through some flex into the critical loads panel at that point. I can also pull a 150 amp feed out of the main panel, run it to the Sol-Ark, come out of the Sol-Ark into the wireway, and that will be my feed for the critical loads panel. So it's a much better scenario to do that than trying to tie in essentially between the main breaker that's outside and the main panel that's in here. And it really allows me a lot of extra control on what gets backed up and what doesn't. Well, here's my progress so far. I've got the wall cut out for the panel. I've also got the wall cut out for some access room up here. And I've essentially got everything roughed in for my gutter to go in. I'm one trip to Home Depot away from having everything I need to start turning off the power and relocating circuits. I found quite a few different things that I'm really not a fan of. and it really seems like they rushed to put this house together, and that's becoming more and more apparent here. So essentially, there's going to be the wireway, the gutter that goes across the top up there. I've got my 2 flexes ready to come in here to this panel, and then all of these Romexes you see in here. I'll show you the gutter here in just a moment, but I've got all the clamps in the wireway there, so those will essentially enter into the wireway, and then I'll extend them and run my 2-inch flex down into this panel, and that'll work out really good. I'm actually a big fan of how that's going. I have here on the right-hand side of this panel the connector for my flex, so that can come in here nice and just make all the circuits on the right-hand side of this panel. It's really starting to come together. It's taken me about 6 to 8 hours of working on this just to get to this point. Essentially, after I go to Home Depot and get a few more materials, I'll be ready to take this panel offline. I'll be able to take this service feeder, the aluminum wire that I didn't like before. I can actually pull it out of the ceiling from up here, and essentially what I'm going to do is I'm going to temporarily feed this panel so that I can keep all the power on. Once that's done, I can demo this panel, get the drywall patched, get everything roughed in for the Sol-Ark, so that way I can get like my flexes into it. They're going to enter in through the back of the inverter. I'm going to get some holes punched through the wall for the batteries, because the batteries are going to be outside, not in the garage. So I'll have a 2-inch conduit going out there for the batteries and a 2-inch conduit going out there for the PV conductors. I'll have a junction box that contains the rapid shutdown transmitter and that sort of thing eventually. For right now, we're going to keep the AC coupled solar, but eventually that's how that's going to go. So I'm planning for the future, getting this together, and yeah, I'm going to go to Home Depot now, and you'll see the progress as it comes, but it's really turning out to be quite nice. This is the wireway or gutter that's going to be going across the top there. I've already got my Romex connectors in here. These are where all those existing circuits are going to enter the wireway. The 2 flexes that are already in are going to go to the main panel that's already in there. I have the 2 knockouts here on the left. Those are what are going to go down to the Sol-Ark for the grid and load side. And then these 2 knockouts here will also have flex. Those will go down to the new critical loads panel, and all sorts of magic will happen inside. I do need to put a few knockouts here to pick up the cables that went to the small sub panel, because those will essentially get diverted back through here to the new critical loads panel. But this is what the wireway looks like so far. This is the back side, what's going to go up against the wall. And I have on all these connectors the screws pointing down, except for one of them. They're pointing down so that I can pull all the Romexes through there and then tighten them all down once this whole wireway is mounted on the wall. So it'll be really nice and convenient for getting that up there. Okay, well, things just kind of accelerated. I want to say out of control, but it was pretty well coordinated. I got some help in here because it was a ton of work getting that gutter up there with all the Romexes feeding into the back. That was a heck of a project, slowly but surely working it in, but pulling each one individually to get it in through the back. But I got that done, and I extended all the circuits into this panel. I know this is a huge jump cut, but we're in and running now. So I'm going to get you guys up close and show you more of the details, how all this took place. It was quite the project, and once we got going, we really didn't want to stop because the power was out to the whole house. You know, it was a time crunch. We'll start here in the main panel. So there was quite a bit of reworking the circuits. A lot of these breakers got moved. You'll notice that sub feed that came in here to that sub panel is gone, and I replaced it with a 2-inch flex. That goes up to the gutter, kind of for future use. Also, there are essentially 2 2-pole circuits I added in here for our EV chargers. So those conveniently use the flex because it was really easy to tie in a conduit to that gutter and then run the wires down. So you'll see there's the 2 60-amp breakers here. Each one of them go to the Tesla wall connectors. I have the big 150-amp breaker up here. I don't know if you'd consider this a 2-pole or a 4-pole. It's a 4-space, but it has 2 poles, so it essentially takes up quite a bit of room, but goes straight up into the wireway through that 2-inch flex. I've got 1-aught conductors coming off of it with a number 6 ground per NEC, And yeah, that kind of covers the main panel. I have a bunch of knockouts here at the top that I will need to be getting some KO seals for, but that will come in the short future. The only thing left in this panel is the AC coupled solar, the mini split for the garage, the 2 HVAC units for the house, the pool pump, which went from, it used to be on a twinned breaker here, a tandem breaker, to its own dedicated 30 amp breaker here. And then we have the electric oven, the 2 car chargers, and then the sub-feed to the Sol-Ark. And you can see here, pretty straightforward, just coming out of the top of this panel are the 2 flexes that then go through a 90-degree flex connector into the back of the gutter. And there is a piece of wood up there. I did need to notch it a bit, but the thing about that piece of wood is it's only there as a block, essentially, for the previous electrician to staple to. It doesn't continue on and isn't actually supporting anything. So that's the only reason I was able to notch it for those flex connectors. Otherwise, that gutter would have had to come off the wall a little bit more. And you can see back here, there are all of those clamps with all the Romexes going in. Yes, there are 2 Romexes per clamp, but that is kosher. The clamps are rated for it. And as you see, all of the screws point down, so I was able to tighten them once the gutter was in. And they're all stapled to that block, so that's code compliant, which is what we want. Similarly here on the other side where the Sol-Ark is, you can see those other circuit that used to go to the sub panel. Those now go into the back of the wireway as well. And then we have a 1/2 inch flex running down here, and that's what's feeding the mini split. So we essentially took that from going into the back of the panel, up to the gutter, and into the main panel. And then of course there are the 2 2-inch flexes that go down the wall into the back of the Sol-Ark. And this is going to be fun to get patched up on the drywall. I'm essentially going to call a drywaller in here because I do electrical, not patchwork. I'm not good at that, so we'll get a drywaller in here. Now, one thing that I did very different from most Sol-Ark installs is that I did not put a wireway at the bottom here. And if you take note, there's air vents there at the back. The wireway would have blocked the air vents, but on the other hand, if we get in here a little closer, I ran all my conduits through the back of the unit, just punched them with a knockout. You can see my flex connectors there in the wall. Then they go into a rigid coupling with a 2-inch, I think it is, or maybe it's a 4-inch rigid nipple. And then if we come up to the inside of the inverter, I essentially have a Myers hub in there. And that's how my wires came in. Essentially, the grid power comes in on the right-hand side. That's going to be this black, red, and white conductor. And I ran my ground in here as well, just as good measure. And then load on the left-hand side. I don't like these loops I had to bend in here, but there was not enough room, or a bend radius, I should say, to come straight into these neutral conductor lugs here. And honestly, this whole neutral and ground bar setup is not good. Sol-Ark has already updated this, but I bought this inverter quite some time ago. I know I could have contacted them for a new bar, but having to do this with the chair lugs was not optimal. And the other thing too, I couldn't really torque these as much as I would have liked to. Now, I didn't go looking up the torque spec, which I really should have, but if you take a close look, you'll see there's a hole right in there, and that's where I snapped one of the studs off the bar, off the neutral bar. Now, had I have snapped another one of the studs off the bar, this install would have been impossible because I wouldn't had enough spaces on the neutral bar for all my connections. So good on Sol-Ark for improving this, but in the meantime, what I had to deal with was not necessarily the best, so that's unfortunate. Also, I would have really liked to see Sol-Ark have support to have the conduits come in the back. I know my installation is a little bit different than traditional, but it works best in this application because I really didn't want to have a wireway at the bottom because we use this garage and it's just another thing that's going to be in our way. In hindsight, the only thing I missed was an additional conduit for the communications. I need to hook the CTs up to my main panel, and I really don't want to have to pull the wire through these same 2-inch flexes that are already full of all these other wires. Now that flex was installed completely, and then we pulled the wire through it, which was quite the task with the back-to-back Flex 90s. Usually Flex is assembled with the wire in it, so essentially you get the wire in and then you put some of the fittings together. That's how it goes most of the time. But crazy enough, I did actually pull the full block, as we'll call it, of all 4 conductors all at once. And I used a fiberglass fish tape and broke it on the first one. Essentially the tip came off the fish tape, but quite the experience. It's in now and we are good to go. And then right now I do have a battery temporarily hooked up, but we'll get into that a bit later. You see the main load breaker in the on position. This inverter's running right now and it seems pretty happy. Oh, and then there's also the 2 conduits on the bottom left. Those go outside. That's where my battery bank long-term will end up. And then I have some test solar panels on there right now because just like a kid in the candy store, I couldn't wait to get this thing doing something. And that takes me to our sub panel, or critical loads panel, we're going to call it. I have my 2-pole breakers in here for things like the washer and dryer, dishwasher disposal, that kind of thing. And then my other single pole 20 amp breakers. There's a lot of breakers. I filled this panel with the exemption of 2 spaces here. I really don't like twin breakers. Yeah, hindsight, I should have done a bigger panel, but in reality, I don't really plan to put much more in this panel, other than, like I kind of mentioned earlier in the video, I would like to put a 50 amp 240 volt receptacle down at the bottom. That's probably going to take up this last double pole breaker, and that's just so if in a power outage, since we only have electric vehicles, well, we do have a diesel truck, but either way, since we mostly drive electric vehicles, it would be nice to have the ability to dump some power from the battery bank into the car, but that'll come in the future. So all of this in this entire panel, every circuit fed out of here is 12 gauge THHN stranded wire, and it's all spliced onto those Romexes up in the gutter. So let's take a look up in the gutter. So starting here on the left, you can see I ran some conduits. Those go over to our Tesla chargers over there. Those are the wall connectors. Anywho, jumping back, sorry if I'm making you guys dizzy. Those conveniently come in. I have the 2 flexes that go down to the Sol-Ark, a handful of circuits there in the back, and if you take note, there is a ground bar in there, and that is for all my ground connections. And yes, it is rated for 2 ground wires, only 1 neutral wire per connector. So yeah, that's all code compliant. That also saved us a ton of circuits going down to the panel. You can see all of my Romexes enter back there, nice and convenient with those connectors. And then they're all spliced on up here. And then the big giant cables going from the main panel to the sub panel, as you would expect. And I've got every circuit tagged with zip ties so I know which hot and neutral correlates to each other. So yeah, all good stuff here. It's ready for the cover to go on and for nobody to ever see again. Some of you guys may have noticed this outlet just hanging out in the breeze. This used to be a GFI outlet. If you actually take a look in this box, it's a really deep box to fit a GFI. Well, when the previous solar company came and added the monitoring box here, they just drilled some holes in the wall, drilled a hole in the side of the box, no connectors, no nothing, just pulled some wires through, changed the outlet from a GFCI to a regular outlet so they had a little bit more room for their connections in the box. And this is the outlet that actually serves, I should say, this is the circuit that serves all of our outlets on the exterior of the home. So that solar company essentially took GFCI protection away from all of the outlets that were on the exterior of our home. And that's the same thing they did up here with that surge protector. Just drilled a hole in the wall, ran it to the panel. Who cares? I'll show you guys outside here in just a moment, but this is essentially the battery bank I'm going to use for now. I have my cables length set already for when I use that outside rack, but for now I'm going to put them in here because that outside rack is about a month and a half away from arriving, and I am a little too eager to get these online. So these are 5 kilowatt hour SOK rack batteries. Essentially I'll have 40 kilowatt hours. I'll tie this into the inverter with those same cables temporarily, and then later on I can use that same cable to go to the outside rack. So yeah, these will be connected here in the near future, and they'll be what we use on the day-to-day basis. Just for now, I have the Fortress Power E-Flex battery. It's great, but I don't necessarily want to shell out the budget for a whole system with those batteries. Temporary solar panels, because I can't wait. All right, so this area on the right is where we're going to pour a little concrete slab and put the battery rack. It's essentially just past our air conditioning units. So let me show you in around the back. You can see there's quite a bit of stuff in the way for running a conduit down there, but I'll show you what my plan is. Since my stub's out essentially lined up perfectly with these AC disconnects, instead of turning that LB to the right and just going over, I'm going to have to go down and put a 90-degree fitting. So essentially this will have a stub here, or essentially a piece of pipe that comes down through a 90-degree connector, dive below all this stuff, run over, and then into the back of that future outdoor rack. So that's the plan for batteries. It's about a 25-foot run in total for the battery cables, but with the right size battery cable, I don't anticipate it being any issue. And here's our existing solar array just for reference. Those are 245 watt panels with microinverters on the back of every single one of them. And that is generating maybe 3,000 watts on a good day, closer to 2,000 on the best days. And here's the existing solar stuff. Essentially a breaker panel with two 15 amp breakers that then goes into an old school analog meter that's reading 60,308 kilowatt hours of generation. And you can see it is currently turning for now. And that just feeds down into a disconnect and then is kind of hacked into the main panel. And behind that cover right there is our main breaker. And you can see the electric meter here, net metering. So yeah, that about sums it up. Well, I really hope you guys enjoyed this video. I hope it being a little skippy and jumpy is not too horrible. I hope you guys got some good ideas out of it. Anyway, but I'll be sure to keep you guys updated and in the loop as anything interesting happens. So thank you for watching. Time to slap the panel covers on, and I'll see you guys in the next video. Bye now.